Hello. Now we are coming to a stage that we need to write the code for this control loop. We already defined all the tags necessarily. Not necessarily to be all the tags, but all the tags for the device code. We need now to do the coding for this loop. So let's make it simple. So we just say that pump will be running as long as the level is not low or low. And it will stop once that the tank drops down to a certain level. It will stop the pump. Okay, let's do the coding first for this pump. Okay, so let's create a function block or a function that is used for like assigned for this control loop. So we'll say level okay. Let's say first network will be pump control. Pump control. Okay. Let's say the pump is start as the tank is getting high. So let's say if the tank, okay, go back here, we get the output. What is the output? Is the pump. So pump. Okay, pump 1, 2, 3. Which one? We'll say the auto command, because this is the command is gonna be used in case of the pump is running in auto. So the auto command for the pump when it is being generated. So okay, we put set reset SR. Okay, when I'll make set reset. Copy here. We don't need here. Okay. So set reset what? Set reset the auto command for the pump. When to reset the auto command? When to make the auto command 1? When do you want to start the pump? I will start the pump as long as the level getting a high alarm. So I put here LT underscore 1, 2, 3 getting high alarm. Once it's getting high alarm, it will start the pump. When it stops the pump, if the level get low alarm. So LT underscore 1, 2, 3 low alarm. So the pump will start at high and it will stop at low level. Once the level hits low, it stops the pump. If the level getting high, it will start the pump. Okay, so it will stop the pump at low, and the pump will be not running as long as the level not getting high. So once the level is increasing, once it hits the high, the pump will start and keep running until it hits the low again. That's very simple code. Okay, that is for the pump. Okay, we already have these tags being created for the level. Okay, what else do we need? We need that level transmitter controlling the control valve. So by the PID controller. So we need to insert the PID controller. So we could put another network. I'll call it PID controller. And insert the library which we done before, PID FP41. Don't override it because we already created last time. Rename it, no. Override it, no. Okay, and this is gonna be our PID 1, 2, 3. Okay, which is PID controller. Okay, we need just to know what these ones mean. Manual on, PV variable, process variable on, P select, I, D, every one of these. Okay, and what that each one of these means. Okay, so this is LMN, which is a manipulated value, which is the value that goes to the control valve. So this is the output of the PID controller. So this need to be assigned for the valve VLV123, the auto value. Okay, what else? We need the PID. This is in case of manual. Yeah, this is manual or auto control will be done, be controlled by SCADA or the human machine interface HMI. This one is complete restart. Do we need to complete restart? No, we don't need that one to assign to anything. Process variable prefer on, keep it. This is a P select, I select, and integral. Do you want to have proportional or integral? Derivative be selected or to be in hold? Yes, I want to be selected. Okay, so we need this one and that one and that one to be on. Okay, what else do we need? Okay, so we need to assign all of these parameters. So let's going through B select, I select. As we said again, we need to enable the integral. Yeah, not necessarily to be always enabled. We can just enable the loop in case of the level is not low. So once the level is not too low, start the PID controller. So we can just what we can do is we can assign a temporary tag here called enable PID controller, which is Boolean, and then after that network, I'm gonna say enable PID controller, and when to enable the PID controller, enable PID when the level, which is LT 123 is not low. So use that inverter. So once this, as long as this one is not low, the PID controller will be enabled, and then we'll use that tag to enable the proportional, integral, and derivative elements. Okay. The cycle. When do you want the PID to be cycled? The sample time. So we'll make it every 2 seconds, but this one in time. So I have to say T hash 2 seconds. Okay. Set point, the internal set point, where the set point needed, like what's the level, we need that level to be at specific set point. So where this set point coming from? So usually the set point is taken from SCADA or from any other control loop. So I'll use it, just leave it as it is and to be assigned from SCADA. What else do we need? The gain, integral value, derivative value, this being driven by SCADA or from the HMI. We need to do it here. The limit, the maximum and lower and minimum limit for the output. So usually this is in case this is real, so this is the minimum, gonna be 0.0, and the maximum gonna be 100%. So the output is oscillating from 0% to 100%. You're gonna hold this one, says high limit and low limit. Okay, I believe that's it. But we need something very important, which is the value. We need the value of the level as a reference. Where to put this one? Here, process variable prefer or process variable in. Let's say, I think, yeah, it's here, PVN. This is where you put the value of that LT. So we're gonna put it here, LT 1 underscore 1 2 3, but the PV. Okay, and we're done for the PID controller. Okay, anything else we need to be done? So the output from that one goes to the control valve. We already said when to start or to stop that pump, and the level. Now the level, that loop is being done. Very simple loop, just consists of 3 networks. The first network is for the pump control. How can we control the pump? So the pump will start and stop with the level. As long as we hit the high level, the pump will start and will be running as long as the tank is not low. Once it hits the low limit, it will stop. And then we enable the PID controller as long as the level is not low. It will enable the PID controller and will take the value of the level and depend on the integral derivative and proportional value, it will put the output to the control valve. Very, very easy and very, very simple. Yeah, I know everyone thought it's gonna be huge coding and a lot of networks. No, it's very simple and straightforward. As long as you know what you are doing, it will be very, very simple coding. If you are not familiar with the libraries, yeah, it might be very confusing for you. Thank you for listening.